Hi, welcome to Bar Math. Today I'm doing a series of videos on exponential formulas. So what I'm going to do is I'm going to take this situation and write it exponentially, but I'm also going to write it as an instantaneous equation. An instantaneous equation has E in it. Okay, the initial size of a population is 500. After 12 minutes, the population is 650. What I need to do first is calculate A, because we're not given A directly. You would be given A directly if you were told a growth factor. We're not given a percent increase or decrease. We just know that we start at 500, multiply by something to get to 650. Well, if I divide by 500, I find out that the 12-minute growth factor is 1.3. That's the 12-minute growth factor. The problem is this says per hour. So we have the 12 minutes. We need the 60-minute. Well, the number of times A multiplies into 60 minutes, 60 divided by 12, is 5. So the A we want is 1.3 to the power of 5. That will 1.3 times 2 times 3 times 4 times 5. That'll get us to a full hour. And we get 3.713. So our formula is going to be f of t equals c. C is our initial, and the initial size is 500, times a, which we just figured out, 3.713 to the t. So there is our exponential function. The instantaneous function uses e to the rt to turn a into e to the r. R is equal to the natural log of a. This makes sense because if we had e to the natural log of a, e and natural log are inverses, so they undo each other, and that would leave you with the initial a that we started off with. So we're going to say r is equal to the natural log of 3.713. So r is equal to 1.31. So now we have everything we need. G of t equals, the initial is still 500, e to the 1.31 t. The last question says, if we were to graph, how would they differ? And the answer is, of course, they wouldn't. They would be the same. They would be the same because they are representing the same situation. They are both exponential models for the same situation, and so their functions graphed would be exactly the same. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!